They attract. They repel. And they put a new spin on modern technology. From your car to your computer. From high-speed trains to high-tech space propulsion. Harnessing a fundamental force of nature as perplexing as it is powerful. Now, magnets on Modern Marvels. Welcome to Six Flags Magic Mountain in Southern California. Here, thrill seekers are taking the ride of their lives on the attraction called Superman. A roller coaster that owes its extreme propulsion and popularity to magnets.
Six Flags wanted to build a roller coaster that went where no coaster had gone before, and that was to break the 100-mile-an-hour barrier. In order to get the speed with conventional coaster technology, we would have had to build a lift with a chain probably close to 500 feet tall in order to get that.
Ride engineers had to find a more innovative solution.
So we turned to magnets and electromagnets in order to generate an acceleration of the car that would break every record that was ever known in the roller coaster world.
Superman uses magnetic devices called linear synchronous motors. Although the technology is complex, the underlying principle is elegantly simple.
Everybody remembers from when they were kids where you had a magnet with a north pole and a south pole, and if you took another magnet and got the two north poles together, they'd repel, put the north to the south, and they would attract each other. And that's fundamentally how this technology works on the ride.
You have magnets on the car. You have electromagnets in the track, and the electromagnets can produce repulsive and attractive forces to move the car. And as soon as the car gets to the place where it's being attracted, the electromagnet changes its polarity, the current changes, and the attractive force turns to a repulsive force. And you keep doing this in synchronism with the motion of the car and produce constant motion.
Banks of computers and switchers shift the electromagnet's polarity in milliseconds. This enables the cars to accelerate from a dead standstill to over 100 miles per hour in just 7 seconds.
To this day, it remains in the record books as the tallest and fastest roller coaster, and we couldn't have done it without magnets and electromagnets.
We rely on magnets for a lot more than thrills at the theme park. They're everywhere, playing a key role in virtually every kind of technology. From our microwaves, to our computers, to our cell phones.
Throughout our house, throughout our car, throughout any office, there are dozens and dozens of magnets doing their work, but without being seen, out of sight, out of mind.
We use magnets without hardly thinking about it every day. Hidden on the stripe of your credit card are little areas of magnetization, like a barcode. And when you swipe that through the card reader, that barcode information is downloaded to the computer.
For many of us, our reliance on magnets goes hand in hand with our inability to fully fathom how they work.
Magnetism is fascinating because of the mysteries. When you have things pulling at a distance without contact, certainly we understand when I push this hand against this hand where the forces are coming from. But when I take a North Pole and bring a North Pole close to it and they push apart, I don't see any contact. And that is always puzzling to people.
Well, a magnet is simply an object that attracts iron. It attracts some other objects that are similar to iron, like cobalt or steel, but it does not attract other things like wood, glass, plastic, copper. So it's a very selective attraction force.
This selective force also has a handy knack for passing on its properties to the iron objects it touches.
This is a bar of steel. Right now it's not magnetized. To show that this is not magnetic, I'll just simply bring it down to the pile of paper clips and nothing gets picked up. All I'm going to do is touch the north pole of this magnet. Doesn't matter what pole you touch. Now, this bar of metal becomes a magnet.
A magnet works its magic by extending its force invisibly beyond itself, creating what's known as a magnetic field.
Now we can make that visible so you can see it with some iron powder. And I'll cover the magnet up and put white piece of paper on there so you can actually see it. And I'll sprinkle some iron powder. These are little tiny particles of iron that will trace out the magnetic field. It's collecting a lot of powder right between the poles, but looping out into space are these magnetic lines. Returning to the South Pole, traveling through the magnet again, and exiting the North Pole in a circular looping fashion.
To understand how a magnet is able to generate its field, we must look to the atoms from which they're made.
If you look at the model of an atom, surrounding the nucleus in orbits are these electrons. These electrons are charged particles. That constitutes a magnetic field. So atoms can be atomic magnets. That's the reason something is magnetic, because of those atomic magnets.
The paired electrons of many substances, however, spin in opposite directions, canceling out their respective magnetic fields. Magnetism results only when more of an atom's electrons are spinning in one direction than in the other, free to emit their magnetic fields. The atomic properties of magnets vary. There are so-called permanent magnets and temporary magnets, like the small bars on CD packages, which can lose their magnetism. To prevent one from triggering the security alarm after you buy a CD, the clerk uses an electromagnet to neutralize or degauss its magnetic field. And what exactly is an electromagnet? Like the name implies, it's any magnet that requires electricity in order to function. Kids have been making the simplest versions for decades. Just wrap some copper wire around a nail and attach the two ends of wire to a battery. The electric current flowing through the coil creates a magnetic field, and the nail becomes a magnet. Disconnect the wire and the magnetic field vanishes. Perhaps no one values an electromagnet more than the junk man. At Columbus Auto Shredding in Ohio, magnets surging with electricity make quick work of scrap metal, bound for recycling centers.
This particular machine works with joysticks, right and left hand. And we swing the machine over the material, stop it, maneuver the boom into place, let the magnet down onto the material. We activate with the right hand the magnet. We've got the material attached. We pull the boom back, pick it up. We swing it over the truck. Then we let it down into the bed, and then we use the left button to de-energize the magnet, let go of the scrap.
This 6-foot wide magnet, capable of hoisting more than 5,000 pounds, was crafted here at Ohio Magnetics, just outside Cleveland.